Hey, fourth grade. Today we're going to move into a new unit, and this is all about how to be a good problem solver. So the first step to being a good problem solver is being able to envision the problem. So I'm going to read you a problem, and I want you to make a picture of it in your mind, just like you do in reading. Really try and understand what is the context of the problem, what is going on. Are you ready? The water slide is the most popular ride at Waterworld. In the first year, 32,543 visitors rode the water slide. In the second year, 56,334 visitors rode the water slide. How many visitors rode the water slide in the first 2 years? Hopefully, if you were envisioning this problem, you probably pictured what a water park looks like. Now, this one's called Waterworld. We know that this water slide is the most popular one. And we're also kind of imagining time, right? We have the first year it's open, and this is how many people rode it. We have the second year it's open. This is how many people rode it. So really get your mind into the world of this problem. Imagine maybe you're a worker and you're there and you're watching people go down this slide and you've been tasked with solving this problem. So after we envision the problem, then we need to reread the question and write a solution statement. How many visitors rode the water slide in the first 2 years? I will answer by saying, in the first 2 years, comma, blank visitors rode the water slide. So now once we get my answer, we should be able to plug it into the sentence and it should make sense if we solved our problem correctly. Now that we've done that, the next step in being a good problem solver is to organize the information given to us. And I like these two strategies the most. Maybe you prefer a different strategy, but I think strip diagrams or number lines are a great way to organize our work. So right here, I have what's called a strip diagram. And I'm gonna fill this in with the information that's given to me. So at the top of the box, that's gonna be my total. And in these two boxes, I'm gonna put the numbers that I have to add together to get that total. Did you know those are called add-ins? So I have one add-in and another add-in. And this problem is telling me that the first year, 32,543 visitors rode the water slide. So I'm gonna put that number right here. That's how many rode it in the first year. And in the second year, 56,334 visitors rode it. So it's trying to ask me how many visitors rode the water slide in the first 2 years. It wants to know the total of these visitors plus these visitors is going to equal a total. So since the problem gives me these two add-ins, I know I'm going to add them together to get my total. Now that I've organized the work given, I know how I need to solve this problem by adding these two numbers. It's time for us to start solving. The first thing I'm going to do to solve this problem is I'm going to line these two numbers up by place value. So I went ahead and did that right here. So now that I've lined those all up by place, I'm going to add each place together. I'm going to add my ones together, my tens, my hundreds, my thousands, my 10,000s. For those of you who are more visual, I'm going to actually go ahead and fill these in with some counters. So this is 3 ones. So I'm gonna drop 3 ones, 4 ones, 4 tens, So now that I know how many is in each place, I just need to add them together. Simple. So I have 3 ones plus 4 ones. In total, I have 7 ones. Okay, I'm gonna scoot these away. I have 4 tens plus 3 tens. That's 10, 20, 30, 40, 50, 60, 70. So I have 70, but because I'm in the tens place, I can just write a 7 here. I know that 7 tens is 70, and that's how many we added together with all these counters. Now for my hundreds, I have 100, 200, 300, 400, 500, 600, 700, 800. Again, I'm just gonna put my 8 here because my 8 is in the hundreds place. Now for my thousands, I have 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000. I have an 8 in the thousands place. And my 10,000. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 10,000s. So when I started with my ones and I added those together. 3 plus 4 is 7 ones. And then my tens. 4 tens plus 3 tens is 7 tens. Then my hundreds. 5 plus 3 is 800. Thousands. 2,000 plus 6,000 is 8,000. And then my 10,000s. This is 30,000 plus 50,000 is 80,000. So I have my answer. That's funny, there's a lot of 8s. I know that in the first 2 years, 88,877 visitors rode the water slide. So that was the missing piece that I found. Now, you don't have to do this big whole thing and use all these counters. You could always just line yours up very carefully
on your paper. And as long as you start with the ones place and make sure you double check your work.
4, 5, 6, 7. 4, 5, 6, 7. You'll get the same answer. Now, if you need something a little more like this to really lay it out for you, totally do that, okay? We have one more step to being a good problem solver. We needed to check for mistakes and reasonableness. We need to ask ourselves, does this make sense? Now, when I go back and check my answer, I'm gonna check and make sure I added all these numbers correctly. And then I'm gonna think, it wanted me to add this first year together with this second year to see what the total visitors had rode this water slide. So my answer was 88,877. Looking at here, I see it's bigger than both of these numbers, which is good because we're combining them, so our answer should be bigger. I'm also noticing, like, if I were to have rounded these numbers, like 50,000 plus 30,000, that does equal 80,000 and then some. So I think this answer makes sense. Let's try this again with a new problem. Let's start by envisioning the problem. Will you envision as I read? A team of artists finished a movie with 122,600 frames. Their next movie will have 179,800 frames. How many more frames will their next movie have than their first movie? So when I hear frames, I think about like the seconds. You know, like in a cartoon, how they have to draw everything. So they draw one moment and then another moment and it all mends together to make a movie. That makes sense. There's a lot of frames in a movie. So I'm gonna reread the question and write my solution statement. How many more frames will their next movie have than their first movie?
How many more frames will their next movie have than their first movie? Their next movie will have blank more frames than their first.
Am I answering the question? How many more frames will their next movie have than their first movie? The next movie will have blank more frames than their first. Okay. So before I do my strip diagram to organize my work, I actually want to show you what a number line would look like. I'm just going to draw a number line up here. Now I'm going to think about the numbers that they gave me. They told me that they finished a movie with 122,600 frames. Their next movie is going to have this many, so I'm just going to put it over here. 179,800 frames. How many more frames will their next movie, that's this one, have than their first movie? That's this one. This is their first movie. This is their second movie. So it's not asking me to combine and find the total amount of frames, is it? No, it wants to know the difference. It wants to know the difference between these two numbers. This one has more than this one. How many more? So how far is this number away from here? The space from this point to this point is going to be our answer. Now I'm thinking about what I know about adding. And I'm thinking if I were to add this number, so I'm going to put that right there. If I were to add it with this jump, this space right here that we don't know, if I added this plus this, that's going to get me to this total. So when we were adding, we didn't know what our total was. Remember? We had our add-ins, but we didn't know our total. Now we know the total, but we're missing an add-in. I think we're going to have to do the opposite of addition to solve this. I think we're going to have to subtract. So let's put our numbers on a place value chart and see what that would look like. So as you can see, I went ahead and lined up my numbers. This is my total. This is my add-in that I'm taking away. And remember, when I subtract, I'm taking away. So I'm not adding counters to these. I'm going to be pulling and taking away from them. So I have 0 ones, and it doesn't want me to take away any ones either. So I'm just going to be left over with 0. 0 tens, I'm not taking away anything. I just have 0. My total has 8 100s, but I'm taking away 6 of those. So if I take away 6 of these, 1, 2, 3, 4, 5, 6, how many am I left with? Just 2. I have 9 thousands, and it wants me to take 2 away. So 1, 2, I'm left with 1, 2, 3, 4, 5, 6, 7. I have 7 10,000s, so 70,000. It wants me to take away 2 10,000s, which is 20,000, so 10, 20,000. I'm left with 1, 2, 3, 4, 5 10,000s. So I'm left with a 5 in the 10,000s place. I only have 100,000, and it wants me to take away 1, so sorry. But I have no 100,000s left. Wait a minute. Do I really need to put that 0 there? Not really. If I take that 0 away, they all stay in the same place, so the number doesn't change, so that looks weird. I'm going to just scratch that out. So the number we have left over is 57,200. So remember, our problem asked us, how many more frames will their next movie have than their first? Their next movie will have 57,200 more frames than their first. Now, let's be good problem solvers and let's check for mistakes and reasonableness. So, 0 minus 0 is 0. 0 minus 0 is 0. 8 minus 6 is 2. 9 minus 2 is 7. 7 minus 2 is 5. 1 minus 1 is 0. Okay, so we think our answer is correct, and I think our answer is reasonable because I was subtracting this from this number. So whatever's here should be less than that total, and it's definitely less than that. I could always, too, to check my work, since this was the missing addend, I could add these two numbers together and see if I get my total. Let's see. I'm lining my numbers up by place value, my first missing addend, or my addend that I was given, and the missing addend that we solved for. They should equal our total. 0 plus 0, 0 plus 0, 6, 7,
8, 7, 8, 9, 5, 6, 7. Nothing to add here, so just 1.
Okay, I must have solved this correctly because these two added up to my total. So today we learned how to be a good problem solver, but we also reviewed how to add and subtract. When we add, we combine two or more quantities to get a total. And when we subtract, we take a number away from a total, or we find the difference between the two numbers. Now, you guys know that we lined up our numbers by place value, and we started with our ones place, and we added each of those places together to get a total or a sum. Did you know the answer to an addition problem is called a sum? Then with subtraction, we kind of did the same thing. We lined them up, but instead of adding these two together, we subtracted. We said 7 minus 4. We took away 4 from 7. And we started with our ones and went all the way across. So you're going to get to practice some of this adding and subtracting and problem solving today. Don't forget, good problem solvers don't rush through their work. They take their time and really make sure that they are thinking about the problems and checking over their work. Have a wonderful math time, 4th grade. I will see you tomorrow.